Why is the Coriolis effect important for ocean currents? Imagine standing on a spinning carousel and trying to throw a ball straight across. The ball appears to curve because of the rotation. This same idea helps us understand how Earth's spin influences ocean currents. The Coriolis effect is a force caused by Earth's rotation that makes moving water veer to the right in the northern hemisphere and to the left in the southern hemisphere. It is a key factor in shaping the paths of ocean currents, which are vital for marine life and climate regulation. When wind blows across the ocean surface, it pushes water in a certain direction. But because of Earth's rotation, the water doesn't flow exactly where the wind blows. Instead, the Coriolis effect causes the water to deflect at an angle, usually between 20 and 45 degrees, depending on how far from the equator you are. This deflection creates a spiral pattern called the Ekman's spiral, where each layer of water moves slightly differently from the one above it. This pattern helps explain how surface currents are organized and how they move across the ocean. The Coriolis effect also leads to the formation of large circular currents called gyres. In the northern hemisphere, these gyres rotate clockwise, while in the southern hemisphere, they spin counterclockwise. These gyres are like giant whirlpools that organize the flow of water across vast ocean areas. They help concentrate nutrients in certain regions and influence weather patterns around the world. Deep ocean currents are also affected by the Coriolis effect. These currents are driven mainly by differences in water temperature and saltiness, known as thermohaline circulation. The Coriolis effect guides these deep flows along the contours of the ocean floor, preventing them from moving randomly. This organized movement helps distribute oxygen and nutrients throughout the ocean, supporting marine ecosystems at all depths. Marine animals relying heavily on these current patterns. Many species, such as whales and sea turtles, migrate along routes shaped by currents that bring food and breeding grounds close to their habitats. Nutrients carried by currents promote the growth of phytoplankton, the tiny plants at the base of the food chain. When upwelling occurs, cold, nutrient-rich water rises to the surface, fueling the growth of these microscopic plants and supporting larger marine animals. The Coriolis effect also influences how larvae and juvenile marine animals disperse across the ocean. These tiny creatures are carried by currents along predictable paths, helping maintain healthy populations over large areas. This dispersal is essential for genetic diversity and resilience among marine species. In addition, the Coriolis effect helps distribute oxygen-rich water from the surface to the deep ocean. This process, called thermohaline circulation, ensures that deep-sea animals have enough oxygen to survive. It also plays a role in climate patterns, as changes in current flow can affect weather and marine ecosystems worldwide. Understanding how the Coriolis effect shapes ocean currents helps scientists predict changes in marine environments. Variations in current strength and direction during seasons or climate events like El Niño can impact fish populations, weather, and even global climate. By studying these patterns, oceanographers can better forecast how shifts in ocean circulation might influence marine life and human activities. In summary, the Coriolis effect is a fundamental force that directs the flow of ocean currents. It influences where nutrients and food sources are transported, determines migration routes for marine animals, and helps maintain the balance of life in the ocean. Without this effect, the ocean's circulation system would be very different, and many marine ecosystems would struggle to thrive.